Hey, what's up, everybody? I'd like to welcome you to another Juice tutorial. And today, rather than doing kind of our normal tutorial stuff, I'm going to actually kind of take a look into the new features in the new Juice that came out a couple weeks ago. Now, I was debating whether to do a video on this because this is a little bit further along than where I'm at with Juice at the moment. And I took a look into the modules, into the demo module, and it was a little bit further. It was quite advanced. But I thought that it would be good just to take a look at it, just to see what we could potentially do and what we'll be able to do in the future with Juice together, and just kind of explore some of the possibilities. So if we just take a look at the release notes, which I will put in the description below, there's a new module called the DSP module, and that provides a set of optimized signal processing routines, algorithms, and also filter building. So you've got examples of finite impulse response filters, infinite impulse response filters, and you can specify the number of coefficients that you would like to build your own filter. So if you wanted to build like a Moog emulation, you can actually take the coefficients and the settings from a website and then use those to actually build an emulation of a Moog filter. Okay. So you've got optimized fast Fourier transform. Okay, if you don't know what fast Fourier transform is, then we can take a look at that in the future. You've also got a convolution engine. So if you wanted to take impulse responses of different reverbs of different rooms, build your own reverb using convolution, then you could do that using this new DSP module. Okay, SIMD optimization, not quite sure what that is yet. I'll have to look at that in the future. So as you can see, this is a little kind of GIF of the demo. I didn't actually see the analyzer in the demo itself. I'm not sure if I looked over that or if that's in a different demo, but it didn't seem to be in there, but it looks really good. And you've also got multi-channel audio support, okay, for surround sound audio files. Okay, so we'll just take a look at the demo patch, just kind of get into that a little bit, take a look at some of the code, see if we can make some sense of it. Okay, and the way we'll do that is if we just go into our applications folder, into the Juice folder, into examples. Now you have two kind of examples here. The first one is module plugin demo. That just seemed to be like kind of a demo of a guitar amp type of simulation. But the one that I found that was more useful to us was this DSP demo. Okay, so if I just open that up in Xcode real quick. This is actually quite interesting, the way that they've done this. So I'm just going to compile the code. While the code's compiling, actually, I'm going to, if you look into this folder, the Juice modules, so these are all of our different modules that we have available to us within Juice. You've got a lot of different tools in here. I haven't really had a chance to look into the code itself, but you have filter design tools. So I'm assuming that you'll be able to specify the number of coefficients that you would want to build your finite impulse response filter or infinite impulse response filter. What we got in containers, not quite sure what that is. So we got frequency. So we got, if we want to implement our own FFT, we can do that here more easily. Then you got your convolution engine. And windowing. So if you have, if you're doing your FFT, you want different windowing functions that define how the frequencies between your different bins behave and how those are kind of cross-faded into each other. Don't want to get into that right now, but there it is if you know what it is. Okay, and looks like some other different stuff that we're able to do with this DSP module. Okay, maths. So if you've got a matrix class here, and lookup table. So I'm assuming this is for like a synthesizer. If you're doing if you need to do really fast calculations, then you can use that class for that. Okay, so and then we've got This is pretty cool. So you got wave shaping, you got finite impulse response filter built in that we can just call up. Got infinite impulse response filter. Got an oscillator that we can call on. Okay, so let's just go ahead and compile the demo here, and it's quite nice the way that this is shown. As I said, I'm not quite clear on how to exactly implement this into the code just yet because I haven't gotten that far yet. But yeah, this is really relevant to what we'll be able to do in the future. So you have convolution. So you can convolve a file with a guitar amplifier or make it sound like a cassette recorder. So let's just take a look at that real quick. In the top left here, you can actually load a file and do like a little demo of what these things sound like. Okay, so just to show you what's actually happening here, if you're not sure on what convolution actually is. Okay, so if I look into my resources folder here, we have a file. It's actually a wave file called cassetterecorder.wave. So let's just play that real quick. Okay, so that's just like an impulse response. You can't even, it's so short you can't even hear it. Okay, got guitar amp.wave. So these are just impulses that have been recorded, and then what they do is, what happens is that on a sample by sample basis, those are combined with our source material here. So like I said, this is something that we'll get into a little bit further down the road. So if I just play the file, just playing, so it just plays as normal. But now let's just change the cabinet type to cassette recorder and watch how it changes things. So it sounds like it's on a cassette recorder, a guitar amplifier. Sort of like a guitar amplifier, I guess. Yeah. Probably sound more like a guitar amplifier if it was a guitar. We got finite impulse response filter. So we have these different blocks of code that I'm assuming we can just take, copy, and paste, or somehow implement it into our plugin in the future. You have your different windowing functions, as I discussed before, but we'll get into that a little bit later down the line. So we could just play this. And you got your cutoffs. So we got filter cutoff here. Same thing, infinite impulse response. So you got Q, which is resonance. Got different types of filters. Bandpass filter. So I'm assuming these are just blocks of code that we can just like implement these quite quickly into our plugin building. You have an oscillator here, and we can just change the wave type. Okay. Change the frequency. You have an overdrive here, which is pretty cool. So it's like a distortion type of effect. SIMD filter, not quite sure what that is. So that's just like a different type of filter. I'll have to look at that in the future. Got state variable filter, so you could go low pass, band pass, and then wave shaper. Okay, so that's it for this demo. As I said, it's a little bit further than where we're at the moment, but I thought it was important for us to kind of go through that together, just to show you that it is there and that we will have these tools available to us in the future when we start building our own instruments and effects. So I hope you like this tutorial. Be sure to download it from the JUCE website. I'll put a link to it below, and see you soon.